Paper 1, question 5. To start off, we've got a cubic function where a is a constant. We're told that f of -6 is 0 and asked to show that a is 4. When you have a show that question, you can't use the answer that you've been given to prove itself. So we answer it in the same way that we would do if the question said, find the value of a. So we do that by using this fact that f of -6 is 0. So substituting in x is -6, so -6 cubed, add a times -6 squared, take away a times -6, add 48 is equal to 0. We can simplify this to give us 48a is equal to 168, and therefore a is equal to 4. Part 2, express f of x as a product of two algebraic factors. So you can either do this by using x plus 6 as one factor, because we know f of -6 is 0, so x plus 6 is a factor, and then filling in the blanks, or you could do it with polynomial division, using the fact that a is 4. And again, divide by x plus 6. I'm going to go for this method because that's the way most of you did it on your homework. So x multiplied by x squared will give me the x cubed. To get the 48 will be 6 times 8, and all I need now is the term in the middle. So to get my x squared terms, I'll have 6x squared here, add this x multiplied by this term, and altogether I need 4x squared, so that must be a -2. And there's my two algebraic factors. Note, if it said linear factors, this is not linear, it's quadratic, so if it wanted it as a product of linear factors, you'd need to factorise this one again, but as it happens, this one won't. For part B, we've got this logarithmic equation and we need to take it out of logs. So we start off using the index law as this coefficient of 2 we can bring up as an index. So we end up with log base 2 of x add 2 squared, add log base 2 x, take away log base 2 x take away 6 is equal to 3. When we have a function like this where we've got a collection of logarithms and a constant, we want to condense all the logarithms into one term. So using the addition law, these two logs that are added we can write as a product. So that would be x add 2 squared multiplied by x, and then the subtraction law tells us we can divide by the x take away 6 to condense that into a single logarithm, which is equal to 3. Now that we've got a single log equals a constant, we can take it out of logs. So 2 to the power of 3 is equal to this function, so x add 2 squared multiplied by x divided by x take away 6. And that will rearrange by multiplying by the x take 6 and then expanding all of this out. Eventually that will lead you to the required form of x cubed add 4x squared take away 4x add 48 is equal to 0. For part C, explain why this has no real roots. So we know that this function can be written in this form as a quadratic when we take it out of logs. And we know that this form as a quadratic can be factorised into x add 6 multiplied by x squared take away 2x add 8. Now, to solve this quadratic, obviously we've got a solution of x is -6. But when we substitute that back into the logarithmic function, if x is -6, log base 2 of -6 that doesn't exist. We cannot take logs of negative values. The logarithmic function itself only exists for values of x greater than 0. So that is not a solution to this equation. It is a solution to the cubic, but it's not a solution to the logarithmic one. And this one, the discriminant is less than 0, therefore there are no real roots, so that gives us no solutions either. And for part C, you have to explain both of those parts, so that this isn't a solution to the logarithmic function and that this yields no solutions from the cubic, so no solutions to the logarithmic one either.